we are on to the next session, which is called the Encoders for AGV and AMR applications by RLS and Nejc from RLS. So I would like to give the word to you, Nejc. If you could unmute yourself, turn on your camera, and yeah, share your screen, then we're excited to hear about what you have to tell us.
So first of all, hi, thanks for joining today. My name is Nejc, and I'll be telling a bit more about the encoders used in AGVs and AMRs. I'm working as a product manager in RLS, specifically on linear ring product line. At the beginning, we'll have a few words about us, RLS, then move to the types of AGVs, AMRs, and the core of the presentation would be how the steering and driving of the guided vehicles works. Afterwards, a few words about the encoders, and for the conclusion, where do we see future of the encoders. So RLS is specified is manufacturer of rotary and linear motion sensors based on magnetic technology. On the picture above, you can see our headquarters in Komenda, close to Ljubljana. We were founded by Janez Novak in 1989, and in year 2000 acquired by Recelj. Recelj is English company, but present worldwide. And RLS currently also uses Recelj sales network, so you can basically find us all around the globe. A few words about our revenue. As you can see below, we are growing, I can say, rapidly. In year 2021, which was just finished, we've made 36.5 million euros. At the moment, about 250 employees. And our mission from the very beginning is to develop new unique solutions for different applications, and that's why we also hold 18 patents at the moment. Whenever we do, let's say, unique product, we try to get a patent for it. And on the right hand side, you can see that our sales are nicely shared. We are present all around the world, not just in Europe or Asia, but also in the States. And now we can move forward to the AGVs. Which type of AGVs do we know? There are many types of them, and just a few listed here: forklifts, guided carts, towing AGVs, unit load handlers, as well as heavy duty AGVs, and all of them work all of them don't work on the same guidance principle. So they can be multi-navigated, they can use laser triangulation, they can be vision guided, scan the barcode, follow the inductive wires, color tapes, magnetic tapes, be gear guided, or at the end, mobile robots use much more smartness, or how can we call that? So basically the difference between the AGVs and mobile robots is that mobile robots use much more sensors and can drive autonomously. You can see on the right side that besides encoders, there are also many other sensors, cameras. The previous presentation has already explained a lot about the other technologies used in mobile robots. And if we look from the, let's say, vehicles perspective, how does it look like? On the left hand side, we see AGVs. They are following a track, they know where to go, and in case they face an obstacle, it's not possible for them to avoid it. So That's the biggest advantage of the mobile robots. On the right hand side, with the camera, for example, they see the space in front of them, and if they have to avoid an obstacle, they do some calculations in the processor and take the best path for them to get to their final spot, or however shall we call that. And in these AGVs or mobile robots, we see different driving units and steering units. Basically, there are three main steering controls. One can be called steer drive, only one motor used at the front. Then we have a differential drive. Here we have two driving systems on the, let's say, middle wheels, and the last one we can say quad drive with a front and back steering system on the AGV. If we look to the drive and quad drive and steer drive, here normally two encoders are used, and one of them is taking control of the driving, of the moving forward and backwards, and for that normally incremental encoders are used, calculating the velocity, and then the second part, the steering control, is controlled by an absolute encoder. Why absolute? Because we always need to know where exactly are we positioned, how much the wheels, for example, are turned. I will talk about the encoders and the characteristics themselves a bit later. And then if you look at the differential drive, we see a control steering unit as on the left hand side. Normally one encoder is used. In most of the applications where we are present, analog output solution is chosen by the customer. You might ask why analog. The reason is just in easier certification, in case the encoder doesn't have a specific certificate itself already. In this case, basically the wheels are turning front and back depending where they want to go, and that's why they don't need an absolute encoder here, because by turning one wheel, let's say one wheel front and the second one back, you can choose also the direction you want to go. So that are the three mostly used driving systems, and let's say two driving and steering units which we see on the market the most. And let's all have a few words about the technology itself. As mentioned at the very beginning, RLS is specified in magnetic encoders only. So all sensing is based on the changing of the magnetic field. On the top, you see let's say a magnetic strip, which is magnetized with a different pole lengths. And then this magnetic field is detected by different sensors. Usually there can be AMR, Hall sensor, GMR, or TMR sensors. It really depends on the encoder and the needs at the end of the day, which one we choose. But generally the technology itself is the same. So any of the sensors mentioned is detecting the magnetic field and bringing the analog signal to the interpolator before coming to the I'm really making it simple now. Before the signal gets into the interpolator, it's amplified to have ideal phases and also the amplitudes of the analog signals. And afterward, then the interpolator gives the output signal as required. The output signal can be just analog, so there is no interpolation done in that case. It can be incremental or analog or absolute. And how we see the encoders used in the in the AGVs or mobile robots. More or less 12 bits of resolution is enough for this specific application, and the accuracy plus minus 0.3 degrees is also good enough for now. The customers choose what kind of output they want to use. We can relate that to the previous slides where I had explained which steering and driving units are on the market currently. So based on that, they choose incremental, analog, or absolute signal. By absolute signal, we see three main protocols used. These are SSI, BIS, and CAN-open. The encoders at the end of the day can be certified with safety standards or not. Our company at the moment do not hold such certifications, but we do not see that as an obstacle. The customers can still take our encoder and certify the system at the end of as the whole system together. So yes, we can say that encoders can have or do not need to have their certification. Depends again on the customers what they prefer. We can say that the environment here is quite demanding, especially if the mobile robots are driven outside on the fields, even in some military applications. And for that, the encoder should be resistant to big temperature changes, to dust, as well as shocks and vibrations. And I can definitely say that that's also the biggest advantage comparing the optical encoders. So currently there are mostly magnetic and optical encoders on the markets and also used in AGVs, but we see that magnetic encoders are well accepted from the customers due to the reasons which I've mentioned before. Of course, optical encoders also have their own advantages, and that are definitely better resolution and accuracy. But as mentioned, magnetic technology for these applications is until now good enough. The encoders themselves can then also can be divided on shaft or hollow shaft solutions. By shaft or hollow shaft, I mean that the shaft solution have a shaft integrated in the encoder itself, or if the motor if the motor has a shaft, we can simply install the encoder on the top of it. And then for the hollow shaft motors, we usually offer ring solutions, which you have also seen on the previous slides. So that were basically the main characteristics of the encoder, the most important one when talking about the encoders used in mobile robots. And now let's have a few words about the future of the encoders, how we see it. We definitely see that the industry would like to take part of the so-called Industry 4.0. By Industry 4.0, we think about the additional sensors already on the encoder itself. By additional sensors, we can say that there are sensors for vibration, temperature, and any others, and such encoder can then predict how long it will work and when the maintenance will be required, or even the replacement. So I can definitely say that such encoders will be more and more present in the future. Another thing that we believe it's very let's say has a good potential are so-called plug-and-play solutions. We know that we live in times where every second almost is important, and the production would like to be optimized as much as possible. The manufacturer of the encoders would not like to take would not like to invest too much time by implementing the solution, and by that it's important that the cooperation between the controller manufacturer and the encoder manufacturer is good, and we can offer the end customer a plug-and-play solution. One more thing that we are already dealing with are supporting softwares. Below you can see a snip from one of our software. It's called Encoders, which can be used with some of our encoders. Such software can give a customer a freedom to set the specifications of the encoder according to their wish. They can see what's going on with the encoder, even get some signals read by the software, and they can easily detect also what kind of errors the encoder is reporting. So such additional softwares are well accepted from the customers, and we are already working on that quite a lot. And then maybe one more thing, where the trend goes, it's definitely a one cable technology. Definitely, I'm sure that Thomas knows about it. That SIG hyperface is more and more used on the market. Not just talking about AGVs itself, but also other applications. Why one cable technology? Because you know that mobile robot, as mentioned at the beginning, has a lot of sensors, and we know that each sensor requires a communication which is driven by cables, of course, and if you have less cables, it's much easier and to install it in the end application. So one cable technology, having less cables in the final solution is something the customers want, and RLS is already implementing SIG hyperface on one of our encoders. So that was basically it from my side. I wanted to give you really the most the fundamentals of the encoder technology, the usage of magnetic encoders in mobile robots and guided vehicles, and didn't want to go too much in details, but of course I'm free to answer any additional questions.
Well, thank you, Nate. It was a good presentation and interesting to see. I'll just take over the screen and share the monitor, and then let the people know again where we can receive the questions. We already received quite some questions during the your presentation, so I'll just go through them. How does the magnetic encoder cope with the external magnetic fields?
Yeah, I mean that's definitely that can be a problem, but it can be prevented by additional shielding with a ferromagnetic metal sheet, for example. So if the encoder is positioned close to strong permanent magnets, which are in electric motors, that can be an issue because, as I said, the sensors itself are reading are detecting the change of the magnetic field, and if they detect additional change of the additional magnetic field from somewhere else, they cannot give an exact position. But as I said, with additional shielding, that can be avoided.
Okay. Then a concrete question: what's the lead time for the US and India on your product?
I can say that we are doing pretty good. Of course, the global situation at the moment is not very convenient for all of us, but we try to avoid long lead times and keep the stock for at least our best sellers. So if we are talking about small quantities, normally lead time is about 10 working days, but yeah, of course we have to know which product exactly the customer would like to have, and so if they would like to have bigger quantities, some forecast is very helpful in this case.
Okay, that's good. Let me see. Aren't at least redundant systems used with AGVs when the AGVs are traveling with people in the same room?
Yeah, I mean, definitely. We also have a solution which is redundant. On the slides, if you maybe remember the one using an analog output, there are two separate on the same PCB. There are two separate electronics. So if one of them stops working, the second one is still okay, and we see that as a good way around if the encoder doesn't have a seal certification in some cases, and some customers are happy to use redundant systems instead of instead of encoders with seal certification or any other.
All right, thank you. How fast should the response be from encoders with the faster update rates from sensors? What's your view on that?
Can you repeat?
Yeah, how fast should the response from the encoders be with the faster update rates from sensors?
I mean, the encoder's response is programmed in advance. I mean, you have some latency which is due to the sensor, and interpolation which should be done, and analog to digital conversions. So I cannot talk about numbers because, again, it depends on the final part number which the customer chooses. But as mentioned, if the customer has an analog output, the latency is shorter than the digital output. Yeah. And when we talk about the frequency, it's completely how the customers would like to choose it, and can be defined with the part number. And I hope that answers the question.
Yeah, well, I think so. It at least gave me some more information. Thank you. How reliable are magnetic encoders versus the optic encoders?
Reliability of both is good. I cannot say that any is better than the second one, but it depends now where we use such encoders. In demanding environments, as AGVs are, for example, I can say that magnetic encoders are more reliable. As you know, optical encoders use optical diode, and if there is a dust or anything on the scale, the output given by the encoder sometimes isn't okay, and for that reason we advise customers rather using the magnetic encoders in demanding environments. And also the entity fee is high in magnetic encoders. We can share that with the customers if that's a question anytime.
Okay. Then another question about differences. What's the difference between incremental and absolute encoders?
By absolute encoder, you always know where you position. So when you plug it in, you know the exact position on the scale or on the ring, for example. By incremental solutions, you do not know where on the track you are until you cross the reference mark. When you cross the reference mark, you know the final position, but until then you just know the changes, how much have you traveled left or right, or how much did you turn the shaft or the ring at the end of the day.
Okay. How to mount a rotary encoder?
I mean, the installation of the encoders is well explained in our videos online, and again, here it's a question which encoder we are talking about. They can be mounted on the shaft or on the hollow shaft motors. So I would definitely advise the customers to follow the instructions in our data sheets, and as well look at the videos which are published.
Okay. Okay. I also got two questions about safety. So one is, if the encoder is non-safety, is the AGV/AMR then also non-safety?
I mean, it's important to say that the non-safety encoder doesn't mean that the encoder isn't safe. Just the final the whole solution should be certified all together, and the encoders with analog output can be certified much easier compared to incremental or absolute encoders.
All right. And then the follow-up question is, what is the price comparison or difference between safety certified and non-safety certified encoders?
Yeah, the safety certified encoders are more expensive, and we know that currently a lot of the customers are decreasing the production cost and looking for a, let's say, cheaper solution. So they then rather take a non-safety encoder in such cases and do the certification by themselves.
All right. Then Multiturn Technology. What is the technology behind the Multiturn Technology, and is Multiturn Technology needed by AGVs or AMRs?
The Multiturn Technology is something that we don't hold in the moment as a so-called energy harvesting solution. We do have multi-turns, but they are not true multi-turns. So when you power it off and move the encoder for less than plus minus 90 degrees, you lose the multi-turn counter. But I know that on the market there is Wiegand wire widely used currently, and that's how most of the multi-turn solutions are implemented.
Okay. Yeah, I think we answered all questions. Your presentation was a bit shorter, so we had more time to answer the questions, which is nice. Oh, wait, another one came in. I'm not sure if I understand this one correctly. It says, which is effective between flux gate and APOS magnet? Maybe you understand the question, Nate?
Which is
effective, maybe most effective, between flux gate and APOS magnet? I will just...
I do not know if I completely understand the question, but I would say that the customer or the listener here would like to know which magnets do we recommend, and we use different materials for different solutions. For let's say on axis solution, we use the ferromagnetic standard magnets made of I cannot remember the material right now, but different material compared to, let's say, linear or ring solutions where we use NBR material. So it depends on the sensor at the end of the day what magnetic material do we recommend.
All right. Thank you for that question, and maybe you can we will share the questions with you.
Sure, yeah.
Next, you can contact different persons to share your answers if it's...
Yeah, sure. Feel free to do that. Yeah.
Okay. Thank you, Nate, for your presentation. It was a valuable addition to the conference, and I think it was clear as well. So yeah, thanks again, and we will be going over to the next session.
Thank you. Bye bye.